Hey folks, how's everyone doing today? Happy Thursday. Bring that down a little, there we go. Alright, got a couple things to talk about today. Let me get PyCharm fired up here. So we had Project 3 due. I know a couple folks wanted to talk about one of the previous labs, and then we got to talk about exceptions and modules. So a little bit jam-packed, but we should be able to get through it without too much trouble here. Come on, PyCharm. Let's work. And then I've got canvas here. Let's take a peek. Oh, I got through almost all your midterms. I got like 5 more to grade there for the midterms. Apologies for the delay. And then Project 2. It's getting a little behind here, I'm sorry. We should be able to get caught back up in the next week or so. Which one do you want to do first, folks? Does anyone have any interest in is it talking about the scores, like the dictionaries and lists lab, or Project 3, or exceptions and modules? You can do either. Start up a new project here. And maybe we'll do that lab first. I know someone had asked me about that on Monday. That was our lab 6. So we'll talk about lab 6 first. So the idea with lab 6, right, is that we were going to make this dictionary of dictionaries, where the first key would be my student, and then the next one would be a dictionary of assignments. Now the problem with that is, and we were kind of trying to fix that with Monday's lab, is that we need to really have 2 entries per assignment. right? The first entry being what the total points possible was, and then the other one being what their actual score was. Because if the only thing I have is their score, I don't. There's no way to really measure that very well. You know, if it's a percentage, that doesn't really mean a whole lot, but I can total up all of the points for them later as we go. So the three options are: you can add an assignment, adds a new assignment to all the users, or we can add a user, a new student. And the trick here with this one is that if they're not the first one, we have to make sure we've got all of the existing assignments already getting added to as well. And then for scoring an assignment, we wanted to ask for the score for each user and update their score that they earned on it. So a couple pieces going on in here. So really, well, we might call that first dictionary like the gradebook. Just start that off as an empty dictionary. And then we want to give them some sort of menu here, right? So maybe we'll, you could even write a menu function. Menu, right? And this might say you want to, and then I don't know, we can do like numbers are pretty easy, right? 1, add a student, maybe 2, add an assignment, or 3, score an assignment. You know, and maybe we might even add in here just for our own helpfulness, like print the gradebook, and that might be useful, right? And then maybe print what 5 to quit, like that, and then we'll get an input. So their choice is an input, and then they probably give us 1, 2, 3, 4, or 5, so maybe we can just return that choice. Sure. We could put it in a validation loop if we wanted to, but this is probably fine here. So we'll get their choice is my menu, and if choice equals a 1, right, we don't even really need to compare it to strings here. We can just do this sort of thing here. We'll ask for the student's name. So the name is input of enter the student's name, and then I can add to my dictionary. Right, I can take my gradebook and I can add a new key of name here. And what it's going to get is an empty dictionary associated with it. Now I need to see if there was another student already. Because this idea, if I'm the first one, fine. But if there's another student in there, I need to copy all of their assignments out with my score being 0. So a couple options, but probably a quick one here. We can check if the length of my gradebook.keys, I get all the keys out, is greater than 1, then I need to go do something. Right, so get all the keys out of the gradebook, check the length. If it's greater than 1, we know we need to go do something here. So what that means is I need to go copy this out. So really, I just need to get one other student copied here. But you know, we can loop through. We can say for student in gradebook, that'll give me the key here. If student does not equal my name, then this is the one I can copy. Because if I get the first one out and it's me, I don't want to copy mine. That's not what I need. So if they don't match here, then we can go through and we want to copy then. So we'll say for assignment in my gradebook, key of the student. Right? Because this is the value associated with that student was another dictionary with the list of assignments. So I want to copy out all of their values and add them into mine, but I want the score to be 0. Right, so this assignment here is going to give me all of the keys, but I don't want the associated values of their score. I want the associated value of the points possible. So we're going to say if the assignment dot points possible is in the assignment, right? Because this was going to be every key in this dictionary here. And remember, we're going to have those two sets of keys. We're going to have the first key being the points possible, and the other key being their actual score. So I'm going to look for this points possible here. If the points possible, then great, I want to copy that whole thing. So I'm going to take my gradebook key of my name, this new student I've just entered, right? That's a dictionary, and I want to add a new key of the assignment, and its value should be my gradebook key of the student I'm copying off of, key of that assignment. This gets kind of screwy looking, right? But it's going to add a new key right? So this is the dictionary that we just added. Gradebook of name, right? We added a new key of the name. Then we're going to add a new key to that dictionary, right? Because we added an empty dictionary there. Key of whatever this assignment was that ends with points possible. We'll add that one there. Then I want to take the next one, right? Else if this was, what do we call this one? Score, right? If it ends with, if a score is in the assignment, I want to do the same thing, but I don't want to give them a copy of their score. I want to give them a score of 0. So either it was the points possible, and I want to copy that value, or it was the score, and I want to give them a 0 for that score until I know otherwise. And then once we've done that, right? Once we've done this one, and this loop is finished, we don't need to go and copy this again here. I mean, it would do the exact same thing, right? But it's more work than we need to here. So essentially we can just break our loop. I know breaks are a little bit ugly here, but this is fine. This means stop copying. We've copied all the assignments out. Now I want to stop this other loop, and I don't need to look at any other students here. Looking through other student keys. Or looping through, right? Looping through other student keys. So far it's not really going to do a whole lot, but that's okay. So now we need to check if my choice is equal to 2. So we need to get the assignment name here. So how about we call it the assignment name to the assignment's name. Assignment's name. And then we also need the points possible. So a points possible is going to be an int of an input. How many points is this assignment worth? Once we have those two, now I'm going to loop through every key in the dictionary. So for student in gradebook, we're going to go through and we're going to take gradebook key of that student. We're going to add a new key given the assignment name plus points possible. We're going to assign that the points possible value. Then we're also going to add another key. Right, this one is just points or score, right? And their score, we're going to start off at 0. So for every student, go add that new assignment with points possible and a score of 0. Okay, and then if the choice was 3, this was going to add a new score and assignment, right? So we need to get the assignment name we wanted to score. So the assignment to score is equal to an input of what assignment you want to score. And then we're going to loop through, right, for student in gradebook. We're going to go get the points possible to tell them. I mean, this is maybe not required, but this is helpful here. We can print that assignment to score has, or had, I don't know, is total points possible, sure, points possible is, and we'll go get the key of student, assignment to score, plus points possible. We'll go get the value associated with that and print it out. Then we need to get their score. So their score is an int of an input of what was the score for, and add in that student name. I'm just going to add in like a colon here to make this be a little bit prettier here. Yeah, we're going to go over project 3 next. Yep, KMP. Okay, so this will just go through and score every student. We'll get the score, and then we're going to take that dictionary key of this, right? This was our score here. We'll assign it the value of score. This was our assignment to score here. So assignment to score underscore score will assign the value of score. And you can see this is really tedious and obnoxious, and it's not great to try and keep a dictionary when now we know about classes. We can use a class to represent this and have some attributes. That's going to make life a whole lot easier for us. But this should work. And then if my choice was 4, we can just print the gradebook. It's not going to be pretty and all. Or, you know, maybe we do this a little bit nicer here. Maybe we'll say for student in gradebook, maybe we'll print the student. Right, that'll be a dictionary. Now that's the key, so key colon, and then gradebook key of student will be their associated dictionary, right? So we can go through and we can see what all of it is here. And really this is sort of a loop here then, right? We'll do this while choice does not equal a 5. You can keep on doing all of this, right? Ask what their choice is. I mean, really, I guess we'll start the menu here and we can say choice equals, I don't know, nothing. Anything to start is fine, because this way the loop will run at least once and it'll ask them every time inside the loop. Should we try it? It's really anything other than a 1, 2, 3, or 4 will, or I guess 5 will make it quit, but the other ones won't do anything. So let's add a student, we'll add Eric, and let's print the gradebook. So now we get Eric with an empty dictionary. So let's add an assignment here. Let's add, how about lab 6? Lab 6 was worth 10 points. And then we'll print the dictionary, or the gradebook. So we get lab 6 points possible, and lab 6 score. Score was 0, points possible was 10. Great, so let's add another student. Let's add Jasmine here. And let's print the gradebook. Now we should see it got copied over, right? But the score didn't get copied. So now if we add an assignment here, 2, let's add lab 7, worth 10 points. We print the gradebook. We should see now Eric has lab 6 score and points possible. Lab 7 points possible and score. Jasmine has lab 6 points possible and score. Lab 7 points possible and score. Now if we go score an assignment, let's score lab 6. I think that's capital L, right? Lab 6, Eric got 10, Jasmine got 5. Sure, why not? And we'll print the gradebook. We see 10 and 5 for scores. Sorry, I can zoom that in here. That was a little tiny. Now if we want to add another student, right, we should be copying those over here. So let's add a student. Let's add my son Jeb. Add him here. We'll print the gradebook. And the score didn't copy, but the lab 6 points possible did. So if I wanted to score an assignment, we can score lab 6. Say, all right, Eric got 10, Jasmine got 5, Jeff got 10. Print it out, and we see they work here. So I think this is all we needed here for that. Does that make sense? So again, kind of funny working with these two-dimensional dictionaries. It gets a little awkward, and then having these 2 different values for every assignment was a little bit funny as well, but that ought to work. All right, so we commit that one. That was lab 6, and I'll start up a new project for project 3. Project 3. Forgot to grab more fluids. That's a bummer. Come on. There we go. That's the wrong one. I wanted 1501. There we go. All right, so lab 6. I don't need any of these other ones here. Right, uncheck all those actually. Pick just the lab 6 ones here to start. We'll do lab 6. Commit those. Knock knock joke. You got it, Trumpet Man. I got my handy dandy pack of knock knock jokes. My little gift shop in town here, just for you folks. Now, I didn't actually need any of these ones, so I'm going to discard these. Ugh, that's going to take a while. We'll come back to that. All right, let's see what we got here. Knock knock. Who's there? Cash. Cashew. No thanks. I'll just take some peanuts. I gotta put that one to the back of the deck now. So I did find Trader Joe's has, I got this as a gift, dark chocolate with coffee in it. I'm super excited for this. Like super excited to try this. And it's these like cute little miniature bars inside of that large one. Let's see how well this works. All right, so this is going to be for project 3. You know, I would rather have a cashew than a peanut as well, but apparently it doesn't go well with the joke. Just mute myself real quick here so you don't have to hear me gnaw. Oh yeah, that's got some good coffee flavor. That'll keep me going. It's been a weird day today. All right, so we're going to do Project 3 was our little Connect 4 game. So we did tic-tac-toe, and then we're going to tackle this one as Connect 4. So this was a two-dimensional list, essentially, right? So a list of lists to get the rows and columns here. And we did a similar thing when we did our tic-tac-toe game. Right, we just kept on asking here. So, it might be easy if we just kind of start with that and modify it. So let's go take a look at that. Go grab our tic-tac-toe. Tic-tac-toe. Oh, that's right. I didn't call it tic-tac-toe, did I? That was our... I'm not even the right... The numbers here, 1500 versus 1501. Now I might have tic-tac-toe. Nope, okay, I still lied. So we need lists and dictionaries. We did that in here, right? Yep, we have all our little functions here. Right, we made the board. We said, well, the game's not over. Essentially this, right, with all of our different functions. Right? So print board. This is Cat's game. It's not the same thing. We'll figure that one out. But win by diagonal, win by column, win by row. Those are similar. If there's a player who won, great. If there's game over, great. But now the board is different. Now, I don't really want to have to do all this by hand if I can help it here. Right, so I'm going to start board off as a single list, and I'll say for row in range. And now there were 6 rows in a tic-tac-toe board. Is that correct? Or a Connect 4 board? Is that right? 4 board. Right, I believe that one is... Yep, 6 rows and 7 columns. Great, so for row and range that, I'm going to take my board, I'm going to add a new list. Right, and then in that list, I'm going to say for column in range 7, take my board at row, right, because I just added it at that index. So this is the index here. We'll call add. I'm going to add a space. So that'll add 6 new lists to be the rows here with 7 spaces each. It'll start off as X's turn. We can play X's and O's. All right, so while not game over. So not Cat's game, so I want to rename this one here to refactor rename. Call this one a tie. Yep, we want to refactor those. All right, so 2 ties, right? Either we tied or someone won. So for a tie, if we found a space, we didn't tie. It's pretty easy here. We could, yeah, actually this is fine, right? If there's a space in the row, we're done. Now, the top row is really all we need to check here, right? Hey, Hector, thank you so much for donating those bits to the Student Scholarship Fund over the U of M Dearborn. Bay, no extra credit for updating after the fact. Yep. Sorry, I remember to watch chat here. All right, so there's our board, right? We know when we can tie or if a player won, so winning here needs to change, right? These wins here. So it's going to be a little bit different here. So by diagonal, we have 2 different ways to win. We have a diagonal up and we have a diagonal down. So I'm going to return win by diagonal up. Given the board, we'll say or win by diagonal down, given the board. Again, just trying to break this up a little bit nicer and easier than what we had here. So we need 2 more functions. We need a win by a diagonal up. We need a win by diagonal down. Okay, so a diagonal up, when I'm thinking of a diagonal going upwards, is, where's that image here? And I think we looked at this, right? We kind of sketched this out where the different starting positions were going to be here. Right, so to go up, you need 4 in a row. So you can only start on the bottom 3 rows. So my rows here are going to be row 5, row 4, row 3, right? Because index 0 is the first row, index 1, index 2. So from index 3, 4, and 5 are the only ones I need to look at starting. So going by up. So I'm going to say for row in range, I'm going to start at 3, right? And I want to go up to 5. So 6 will give me up to 5, but not including 6. And this really, I'm going to call this a row index because this might make life a little bit cleaner here. So for row index in range, now we need to see every column. Right, if I'm going up, my columns here will start at 0, and I'll go 1, 2, and 3 because I can't get past column 3. Right, so I'm going to say for column index in range, and now 4 will give me 0, 1, 2, and 3. Right? Now I'm going to say if the board at row index at column index, right? So this is the two-dimensional location, this row index, this column index, right? If that is not equal an empty space, right? And when we're going diagonal up, so I'm going to just bump this down a line, it equals, so to go diagonal up means I'm decreasing the row, so that's row index -1 and column +1, right? So to get from my very first row here, which was row index 5, column index 0, I'm going to go up a row, row -1, column +1. Up a row plus a column, minus a row plus a column. And I'll check those 4. So I can just check all of those if they all match, right? We'll do and those ones match. Oh goodness, the tabbing here is a little bit funky, sorry. So then -2 +2. And these ones match, right? -3 +3. If those are all true, I can return true. Oh, I need my backslashes here, sorry. When I'm going down a line, you got to add those backslashes to tell it, yes, I really did want to go down a line. Just format's a little bit funny. If I've gone through all of these here and I haven't returned a true, I can return a false. I have not won by a diagonal up. Does that make sense? We start at a given row index that's low, so we can take minus, 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 because I'm never going to be less than 3. So row index -3 is a valid index. I'm going to check the valid indexes. We do essentially the same thing for diagonal downs, but we're doing from 0 to 4, which will give me 0, 1, 2, and 3. Is 3 right? Nope, 3 is too far. Right, so 0, 1, and 2. Right? I want 0, 1, and 2, because I need to be able to get 4 down. Now, my columns are still increasing, right? But my rows now need to be increasing. Right? If I found that, if it's not empty and they all match, I return true. Otherwise, I can return a false. Why does it not like my tabbing here? Oh, that's fine. It's okay. Probably should be tabbed in one more or something funny like that. We can't do backwards. You like it like that? That's a little ugly, but sure, why not? Okay. So that's my diagonal up, my diagonal down. Win by a diagonal is either one of those. Win by column now. So to win by a column, I need to go through all the possible columns. So that was range of 7, right? Because we have columns 0, 1, 2, 3, 4, 5, and 6. So for every column, now I need to check every row. So for row index in range. Now, if I have 4 in a row, right, I can only look at columns 0, or row 0, row 1, and row 2, right, to make sure they all match. So I'm going to go range of 3 to give me 0 through 2. I'm going to check, hey, if my board at row index, row index, column index does not equal blank, right, and they match, right? So this is going down columns every time. I need one more of these here. So to go down, right, if I'm 1 in a column, I'm just increasing my row +1. Oh, sorry, I'll do it on this side, right? +1, +2, and +3. Right? Those should all match. If they do, I return a true. If I've looked at every column and every starting row, so with my rows, right, I could either get a 4 in a row from the row 0, 1, 2, and 3, or 4 in a row at row 1, 2, 3, 4, or at row 2, 3, 4, 5 for each given column. So I need to check each starting one here. Does that make sense, KMP? Yeah, cool. All right, so it's winning by column, and now winning by row. For every row, I need to check. Now there's the columns I need to look at. To get 4 in a row, the last column I can be at is at column index 3. Right? 0, 1, 2, 3. So starting at each column index, 0 through 3, I need to look for a 4 in a row. So for row and board, and really this is row index in range. So you can do it each row at a time, but it gets a little funky that way, and I prefer, since we're doing this two-dimensional, we'll just stick to two-dimensional. So for row index range 6, we need all possible rows here, right? And then for column index in range 4, right, because I want, range 0, 1, 2, and 3. Yeah, I do want range 4. 0, 1, 2, and 3. If my board... okay, sure, we can do that then. So for row in board, that's prettier. Row in board. And for column index in range 4. If the row, right, at column index, not equal to that, and my row at column index equals the row at column index plus 1, and there we go with my slash. Come on, get the slashes here. Column index plus 2, column index plus 3. My goodness, that copy paste got really funny there. Wow, sorry, this one's a little ugly here. Okay, so we're going to start. So for each row in the board, I can just take the row out, which is a single dimensional list then. I can say, let's check at column indexes, starting through range 0 through 4. If it's not blank, and it matches the first, plus second, plus third. We return true, if not, we return false. Player 1 then is winning by row, column, or diagonal. The game over is whether or not we tied, or that a player had won. And then we'll go build our board. We figure out it's X's turn. We say, well, not game over, it's someone's turn. Now this one here, we just need the column here. So the column is going to be, right, enter the column, drop your piece. Right, I'm going to tell them it's 0 through 6, right? And if, now this one's a little bit different here, right? If the board, not at the row here, right, but this is always going to be row index 0, right? I only need to check the top one. If that column does not equal blank, you can't go there, because I only need to check the top row, right? If there's not a piece at the top row, there's room for you to drop a piece in. But if there's a piece at row 0, that column's full, right? And we need to reassign here. Then we need to figure out how we drop the piece, right? So let's add another function here. Sorry, not there. Let's go up a little bit. Let's do drop piece in column, given the board and the column index. Okay, so if it was good, then I can call drop piece in column, given the board and the column index. And probably let's just turn that into an integer now to make life easy for us here. Okay, our whose turn stays the same. Right, so then to drop a piece in a column, we're going to check, we need to start at the bottom up. So I'm going to say for row index in range, I'm going to start at 5. I want to go up to 0, so I need to get to -1, stepping -1 at a time. Right, so I need 5, 4, 3, 2, 1, 0, and then stop. So this is doing a range backwards here. If you wanted to, you could also just give it your own tuple. Just give it 543210. That's perfectly fine. So you can say if my board at row index, column index is blank, then, oh, we need to know whose turn is it too. Sorry, that's a whose turn. Whose turn as well. You also need to tell them whose turn it is, because they need to know what piece to drop in there. If it's blank, then great. We'll take that and we'll drop the piece. Equals whose turn. Then we want to break our loop. Break the for loop. Right? If that row index was full, go to the next row index. So if row 5 was full, go to row 4. If that was full, go to row 3, row 2, on and on and on and on. We'll drop a piece. Nice, let's try it. Uh-oh. List has no add. It's append, I'm sorry. Append. Sorry here. Appends. There we go. Right, so the blank board here, right? It's X's turn. Where should we go? Let's play Connect 4 real quick. You think of a move, I'm gonna go back on mute, eat some chocolate, and we'll play Connect 4. All right, we got a game here between KMP and Bay. It's your turn, Bay. Got X's versus O's. It's the classic showdown. Two. All right, you've been blocked. Getting a 4 in a row that direction. You're going to take a 4 in a row to the right. Let's go KMP. Oh, he's just going to stack up. There we go. All right, Bay. He didn't take the bait. He didn't try and go right. Let's see what we got here. All right, here we go. We're going for that diagonal win, it looks like. Let's go KMP. All right, you gotta block him now. Don't lose now, Bay. All right, KMP, he blocked you. No easy win yet. You gotta fight for it. You're gonna have to fight for this one. Where you go next? 5. All right. Bay, he's forcing your hand here. He's gonna make you move. If you don't want to lose. Let's go. Let's see it. Let's see your drop. 6. There we go. All right. Still no easy win. You're gonna make him work for it here. KMP, where you go next? 3. Oh, okay. Interesting. Got a 3 in a row there, but column 2's not filling up anytime fast. All right, Bay, it's your turn. Zero. All right. You got a 2 in a row now. 5. Uh-oh. This is looking scary. You're just asking for him to block you there, KMP, aren't you? You got tricks up your sleeve? All right, is he gonna take the bait? You think? Is Bay gonna block you there in column 5? Or does he have some other trick? 1. Ooh. There we go. That's interesting. He's not taking the bait, KMP. He knows you don't have the 4 in a row yet. There's no pressure. There's just 2 3 in a row. 3 different 3 in a rows. No? Okay. Okay. All right, 2 different diagonals. Getting the 3 in a row. That column 2 is going to be dangerous. You got to win on either one of those squares coming up there. Hey, you're going to have to beat him before column 2 fills up. He's got an automatic win there. 2 3 in a row. What you got, Bay? On, represent the O's. Here we go. Column 0. All right, KMP. Keep your eyes on the prize. Don't lose now. You're setting up a good trap there in column 2. He saw it. He saw it, Bay. He blocked you there. What else you got? Got to get that 4 in a row. 2. All right, stack it up there. That is the dangerous column there, my friend. Well, you could win first, but column 2 is gonna make you lose pretty much automatically here. If once column 2 gets another piece in it, he's got wins at row 1 or row 2 with those 2 diagonals. You won't be able to block him once that fills up. So you got to win before column 2 fills up. Got to find another place to win. That's all. 5. All right, there we go. Okay, you put the block there in 5. That's good. That's good. All right, KMP. You can go for the win now. All you got to do. All right, KMP is going for the trap. He has got 2 different places to make a 4 in a row now, either column 1 or column 2. You can't block them both, Bay. I believe we're heading for a game over here. No tie game this round. KMP is the reigning champion of Connect 4 for the course. 2, all right. You're going to let him have the 4 in a row by row. Here we go. Let's see if my code works and if it figures a win here. KMP, ready for that knockout? Let's go for the KO. Uh-oh. He's not going for it. He's not going for it. 4. 4. Oh, there's another diagonal win. I didn't even see that diagonal win. My goodness. Game over. KO. Good game, good game, good game. I thought you were going to go here. Get this 4 in a row. Well played. Well played, friends. Thank you. So, seems so far to be working. Hey, KMP, you get some bonus points. Do an exclamation bonus in the chat there. Hat, you got it. I don't have my usual one here, so I'm going to go with my daughter's big floppy hat, if you don't mind. We'll take this one here. Yeah, bonus points here. I think it's bonus, right? Bonus points? Which one is it? There we go. Bonus points. Exclamation bonus points. You get some bonus points there. All right, so how do you feel about Project 3? Again, still breaking this up, breaking it down little bit by little bit by little bit, one little function after another. That's sort of the goal here. Trumpet Man, you name it here. You pick as many bonus points as you want, my friend. It's like whose line is it anyway? The points don't actually matter. They're pretend bonus points. Okay. So I think we did pretty good here with our Connect 4. Again, you didn't have to do it by loops, right? There's ways you could have just looked at every different possible row combination, column combination, but that's more work than you needed to do, right? So if we could figure out these loops, we can work, do a little bit less work, right? Make it a little easier for us here with these diagonals, right? So it works out pretty well. Okay, so I'll get that one committed here. We'll do project 3. Commit that one here. Oh, project 3. How many possible winning combinations are there? Oh my goodness. That's a question for Google, not for me. How many ways to win Connect 4? How many ways are there to win? This is how to win. No idea what this website is. Iron Set. I don't know what that means. Is it just the number there? 212,000? That sounds about right, maybe? I don't know if that's still a thing. What is this? Okay, this website looks like garbage. Let's not go to that garbage site. Quora.com. Here we go. People answer questions there sometimes. And I'm sorry, I think I keep dropping frames. I think my Wi-Fi is having trouble. I forgot to reboot before class. Yep, more drop frames. I'm sorry. Hopefully it's not too bad here. Really? 4.5 trillion? That doesn't seem right. Pretty sure that's not right, but what do I know? What do I know? All right, and this I don't need. I can discard all these. Wow, what's my computer doing? Got all sad all of a sudden. Checking Task Manager here real quick. See what I gotta kill. That doesn't seem too bad. What's going on here? Yeah, OBS. Yeah, okay. Oh, this desktop window. This one is the worst. This like randomly seems to spike. I haven't figured out how to fix that one yet. But okay, possible combinations of pieces. Okay, because that's just 2 to the what 42nd or something. Oh, but not right because it can only be every other. So I don't know. I'm sure we could figure that out, but the math is not coming to me at the moment, right? Because we've got 42 different spaces here on the board, and each one can be one or the other. But really, you can only take up 21. But like, not all the possible combinations are valid though. Like once you have a 4 in a row, the game's over. So you can't have other permutations of this board with 4 X's in a row, right? Like you can't have. I guess you could have other. Okay, so you could have other pieces in here, but not. Because you have to stop as soon as there's a 4 in a row. So you could fill the rest of the columns, I guess, with everything except the winning position. So I guess if you fill everything except one column, maybe, and you leave that last column to like slot in the win, then yeah, you could do any other combination of things. But oh, that sounds obnoxious. I don't know how to do that math problem. That's a great permutation combination sort of problem, right? I'll leave that up to the math folks. All right. Oh goodness, we are almost out of time already. We haven't even talked about exceptions or modules. So real quick, modules are crazy easy. So we'll just look at exceptions and modules. So we've actually kind of done the module thing already when I looked at classes and showed you how you can put a class in its own file. A module in Python is just another Python file. So we always get started off with like this main one here. If you make other files, you just say, hey, I want a new Python file. and we put in here, I don't know, my stuff. And then in my stuff, we can define functions. I don't know, add a and b, and we'll return a plus b. This is like stupid here, but that's fine. And we'll define subtract given a and b, return a minus b. Sure. So nothing interesting here, but we've got two functions here. If we want to use those functions from another file, we want to import. So we're going to say import my stuff. Okay. I've now said, hey, give me everything that's in the my stuff folder. Now I can't just say add. So to get at it, I need to say my stuff.add. I can add a and b, or my stuff.subtract. What we did before with our classes here, we said from my stuff. So from module, import add. And now I can just say add, because I've imported it specifically by name from a module. That's why, like when we did random, we said import random. We said random.randint, because it's the random module randint. You can import module name, import by module name, Python file name, or from a module, from a file, import functions or classes by name. Like that was, from my stuff, import add. And now I could just say add. Right, and I don't know, 1 and 2, sure. Now, if we wanted to, we can also say from random import randint. Right, and then I could just say randint. Right, like that, instead of random. And notice it's going to gray out the ones we're not using here, which is kind of fun. 0 to 10 or something, right? Or 1, I don't know, 1 to 9, sure, it doesn't really matter. Those are modules. So when we import, we're looking locally here, and we're also going to look into the Python library. So when we install Python, let's see where mine's actually installed here. I think it's in C Python, C program files, Python. Other program files maybe? Python? No, it's not. Okay, I should know where it is here, but I go to File, Settings, probably in my users directory, in your Python interpreter. Okay, mine is at C users Eric app data local programs Python 3.9. Sure, that's a terrible path, but we can find that. So C users Eric said local app data local programs Python. Nope, I missed an H there. Python. Oh, come on. C users. Eric C. Eric C. Data local programs. Okay, fine. C. I'll do it by hand. Users. Eric. App data. Local. No. Local. Programs. Python. Python 3.9. Here's where Python is installed. Inside of here is this little lib folder. This is all of the built-in stuff into the Python library. It's all out here. There's a random file here. This is the random module. So we can open this one up if we wanted to. Come on. Open. Open. Open with PyCharm. There it goes. Oh, I had that other window open. So this is the random file here, and you can see everything, how Python does things. See, there's a bunch of other funny things in here, and most of it's not going to make a whole lot of sense here, but if we look up randint, here's randint, given a and b, returns random range of a, b plus 1. Right, well, so what is rand range? Here you go, random range is a start and a stop, stepping by 1. It's going to go through and check, make sure we have a start, make sure stop. If it's not none, we get a value here. It says, okay, sure, it has to be integers. If step is 1, great. We're going to do rand below, sure, whatever this thing is. Rand below. My goodness. Do we even have it in here? Where'd it go? Oh, you can inherit it. Oh, geez. Sure. And it looks like that's coming from another library somewhere. I don't remember. But you can kind of dig in and you can see all of that fun stuff in the Python library anywhere that you want. So you can import any of these, right, that come from the Python library. And it just works for us. So that's how modules work. So modules' great exceptions are when something's going to crash. Right? I don't remember if we actually talked too much about exceptions so far. But if we just do, like, here's the main, and we said we wanted, oh, right here it is. So if we wanted an int of an input of enter a number, 1 to 10, and we'll say here's my number is equal to this. Right? We just run this here. Enter a number, and I enter like ABC. We get a value error. This is an exception. A bad thing happened, and it crashed our program. Now, we don't want bad things to crash our programs. Right? That's not the goal here. So what we can do is we can put this in something called a try block. And then in a try block, it says we're going to do this thing, and then except if something happens here. I need a value error. Is it as E or something? An E? I forget all the syntax here. This is probably right. I could go check the iBook, but I forgot to open it. So if I enter ABC, something here, I get, this is the message here, invalid literal for int with base 10, so I can't turn that into an integer, but it didn't crash the program. And I can do this in some sort of loop, like while true, and do this sort of thing here. And then if we successfully do number, we can break our loop, right? Or, we can set some sort of flag, either way you want. Like, is valid number is false, and while, all right, is invalid number equals true, and we'll say, okay, while is invalid number is true, and then if we get a valid number, we can set that to false. Then we're done. Now we say, hey, I get a, I get my number. I don't know, we'll do like times 10. This try is saying an exception might happen. It might happen. Get ready to catch it. This idea with try and except, if there's an exception, we can handle it here in this except block. Maybe handle it. So if I know an exception could happen, I can put it inside of a try block, and then at my except block, I can do something with that exception instead of crashing. This is handle the exception and don't crash. So eventually we'll get a valid number here. I get a valid number, and now it's going to work. So I can deal with bad input here in this case, this sort of way. Okay. The other cool thing we can do with this is if we write our own classes here. So what class do we do before? Let me take a look at our GitHub. Let's grab this down here. I want to save a little bit of time here. Looked at our classes. We looked at testing, was great. Excuse me. Oh yeah, electric vehicle, great. So let's copy electric vehicle. Let's do, how about mug? Mug is fun too. We'll do mug. So I'm going to add a new class here for mug. I'll have a class for mug. And then I can say from mug, import mug, capital M mug, right? And I can do stuff with mug, right? So my coffee mug equals a mug, and then mug wanted in the constructor, right? This init method, a size and a color. So I have to give it a size and a color. So, okay, this was 300 milliliters, and the color was blue. Blue, right? So this is probably 300 milliliters worth of blue mug, right? Although, I mean, blue's not a great description here, but generally it's a blue mug here. Well, even knows I spelled coffee wrong. Thank you, PyCharm. You're so helpful. Okay. Then what we're going to do with that, we're going to take our coffee mug, dot, and use all these public methods. Right? If I wanted to drink out of it and say drink 500 milliliters, the only thing mug did right now is stop if we got to be less than 0. But what I can do inside my class here to say, hey, whatever you tried to do failed, I can say raise, what is it, a value argument error or something? What is it? Some sort of error here. I will just say value error, sure. You can't drink that many milliliters. Milliliters. 2 L's. So I'm going to raise a value error if this bad thing happened and make them handle it or crash. So if I try and drink 500 here, enter a number, sure, we get a value error. You can't drink that many milliliters. So using an exception or an error like that forces whoever's using my class to deal with the bad thing that they did. Right? So far we just said, oh, we're just going to ignore it and say, okay, I'm still going to maintain the integrity of my class. I can't have a negative volume. But I had no way of communicating to whoever used drink that, hey, you wanted to drink 10,000 milliliters? I'm just a coffee cup. I don't have 10,000 milliliters worth of liquid here. Go get lost. Right? That sort of thing. So using exceptions here and raising an exception is the way that we communicate to other classes that a bad thing happened. Now, this isn't for regular cases. It's not for regular communication, right? We could return some sort of value if it's supposed to be some sort of regular process, but we can use exceptions to force them to deal with it or crash. So they could do the same thing. They could do this in a try block. And they could try and then accept a value error, I don't know, as E, and print E or something. I mean, printing the error is not the most useful thing all the time, but sometimes it's useful here. And maybe we'll say, here's an int, I don't know, how much to drink is an int of an input. How many milliliters? Milliliters do you want to drink? And then we'll try and drink that, how much to drink. Right? And let's try that. So we should be able to drink, actually none, right? Or do we start them as full? I don't remember here. So if I drink 10, you can't drink that many milliliters. Right? That was the message here in that error, right? Because we never filled it. So maybe we should fill our coffee mug. So coffee mug.fill. We fill it first. Now we should be able to drink some, but not more than 300, right? So if I drink 50, that's fine. I was able to drink 50. But if I try and drink more than that, right? If I try and drink 350, I can't drink that many. Again, we can do better things with our messages here, but the idea is that my classes can take advantage of exceptions to communicate that you did an exceptionally bad thing, right? Same with like electric vehicle. Maybe we could have said, oh, hey, if you try and drive too far, right? Instead of just returning a false, like, sure, maybe they were watching for that. We could raise an exception and force them to deal with that they couldn't drive that far. Because it's possible they just kind of ignore the true or false. But if we raise an exception, they have no choice but to deal with it or crash. And no one wants their program to crash, because crashing programs is ugly and bad form. No one wants that to happen. All right, that's the quick take on this. We can spend a little bit more time. We'll practice it in lab, trying to deal with our own exceptions. We really get deeper into this in the next semester in 2001, which apparently we scheduled badly, because I think 3 of you now have said there's a Tuesday afternoon class during our lab time that you all need to take. I'm really sorry about that. I didn't schedule it. I wasn't a part of scheduling it. Not to pass the buck, but like my department chair said, this is when the course is. And I said, okay. So someone somewhere didn't look for conflicts. So I don't know what class is Tuesday afternoon that a lot of you want to take. But we're going to follow that same format where the lecture time and lab time are optional. If you're turning the things in, great. That's how you're going to get assessed, by the things that you turn in. Ideally, you can come to lab time, because that's your chance to ask me questions, but you can always meet with me during office hours or other times, and I can help talk you through anything you got stuck on. Because there's no real lecture in our lab time, so I'm not recording anything. Sometimes I'll do a little bit of a demo and post that code, like here's some starter code or some ideas to get you started. So I'll make sure I post that kind of stuff on GitHub, if I do post any of those. But beyond that, again, it's totally up to you if you want to come. Ideally, you do when you're putting in the practice, but if you're double booked, go do the class you have to be at, and then you can work on the lab at another time, and we can chat about it during my office hours. We can try and make that work next semester. So just let me know. And then I think we need to talk about the final project, right? I think that was the last thing we had to do on our agenda. Trumpet Man, I don't remember. The people who asked me about it didn't tell me what it was. They just said, hey, there's another class that I need to take. So I don't know, maybe someone will chat in the Discord, or if they're online now, they can let us know. But that's sort of the plan. All right. Yeah, so we want to talk about... Oh, we've got... Yeah, because I wanted to talk about it today, so we've got the rest of the time. And then if you want to take the Thanksgiving break off, you can actually have that whole week off. Because we're off that whole week as well. So our last project then is going to be using classes, right? So it'll be a class-based project. And that should be a lot of fun. So we'll see how well this one goes. So give me just a second here. I got to go pull this one up from over here. Oh man, I don't even remember when that was. That's fine. That's fine. Okay, so this will be our final project. Come on, Canvas, get loading here. And again, if you'd like to work on this in pairs, I would definitely encourage that for this final project. Given that we're still in the middle of a global pandemic, I totally understand if you're not comfortable working in pairs with people, so totally up to you. But it's the same project either way, because if you are in pairs, there's more work involved in collaboration. Then you save not necessarily having to do all of it yourself. So just keep that in mind. Let me grab my little chocolate bar here real quick. Put myself on mute for a second. All right, I'm back here. Yeah, definitely submit the same code. No, they don't have to be different at all. If you work in pairs, you are welcome to be identical, right? That's sort of the idea. If you'd like to be in pairs, I can actually set you up with a shared GitHub repository that you both have access to make commits and polls from. It takes a little bit of extra collaboration to make sure you're not blowing away someone else's work or potentially getting into that. Git is really good about that, but often what it does is it just doesn't let you make the change, and then you have to deal with it, and there's this whole merge conflict idea that, you know, it's something we can learn about at another time. But I can help pairs with it if you'd like. All right, sorry about that. I ate my chocolate. All right, so what we're going to do is we're going to build a Powerball ticket simulator. So Powerball is a wildly popular lottery because people in America love losing money and giving it away to the government. You know, aside from taxes, like they just literally give the money away to the government here. Still, sure, I don't understand it. But the idea with Powerball is that you have 5 white numbers that come out of a single bucket. So 5 white numbers, 1 to 69, with no repeats allowed. GG Hockey, yeah, you need to ask somebody for an override somewhere, and someone had told me all you need from me is a statement saying attendance is optional, right? And I'm happy to work with you to turn things in separately or something like that. So usually they'll ask you to contact the instructor to make sure it's fine. And I can explain or, give you a little email blurb that, yes, this is, an asynchronous optional format for you and attendance is not required. And then they should be able to override it. So apologies for that overlapping scheduling again. Not that it'll help you, but next winter semester, hopefully I can see whatever that overlap was. If someone wants to tell me, that'd be great. And we can change the lab time. So my department chair, I think, did move it for me because I said I can't come to campus 3 days a week and I would just quit. So he's like, okay, I'll move the lab time for you and you can just come to campus 2 days a week. And I was like, okay, that'll work. I just making the drive out there 3 days a week to teach one class was a bit excessive for just to be fair for what I get out of it. So he moved the lab to be before our class on Tuesday for me. And I guess that had some more conflicts, so apologies for that. But Powerball, right? 5 white numbers, 1 to 69 here with no repeats. And the way that you win is by combination, not permutation. So your first white number could be the same as the 5th white number in the winning ticket. No problem. Okay. Yeah, stat. Okay, yeah, as long as you can take them. Someone had said it was a required course at some point. But yeah, if it works, great. If not, happy to be flexible. So 1 to 69 with no repeats, and then there's a red ball, 1 to 26. So we're going to let the users pick their numbers to buy one ticket or buy X number of randomly generated tickets. So some people have superstitions and they think their numbers are more lucky than others, and they've never took a statistics class and don't understand how that works. And other people just buy a random ticket because they understand how statistics work, and everyone has the exact same odds of winning. So sure. So if they want to buy random tickets, they'll say, hey, I want to buy 1 million tickets, whatever happens to be here. So the odds and price chart is my favorite part here. The odds of getting a exact match here, and again, in combination, not permutation, 292,201,338 to get 5 white numbers matching 1 to 69 plus the red number 1 to 26 matching. Okay, so there's a little bit of an overlap till 3:45 for the 3:30 start. Okay. Yeah, either one is fine. So yeah, definitely the lab is 12 to 1:45 Tuesdays. The Tuesday, Thursday, we don't have a room assigned yet. So usually they do that like 2 days before classes start for, I don't know why reasons. I'm just not involved in that process. You can complain to the registrar. Tell them they should understand how this works, scheduling, but okay, sure. It might have something to do with class sizes. So like if certain classes get more than 30, they need to find the bigger rooms. But again, I think that's just lazy. But that's just me. So some people will say, oh, sure, we'll just buy 292 million tickets and get every single possibility. Now, the problem with that is you can't fill out 292 million bet slips to pick every single possible combination. And if you buy 292 million random tickets, you're likely to get some, I guess, the odds of you getting a repeat is that you're likely to get one repeat at that point, right? Is that how that works math-wise? Right, every ticket gives you one more chance to get a repeat. I forget. There's some fun math there, but so if you win that, you win the grand prize. Feel free to put in like $1 billion. Just make it up. You don't need to be tracking a grand prize like everyone likes to advertise how much the grand prize is. That really doesn't matter. If you get all 5 white, you get $1 million. 4 white and a red, 50,000. 4 white, 100 on your way down. So each ticket costs you $2 to play, and you'll win starting $4 and up if you match the red number 1 in 26. Now, I don't understand this odds here to match the red ball, but it's not. The reason why it's not 1 in 26 is that's the odds of matching the red and not matching any of the 5 white is why it's not 1 in 26. So it's actually less likely that you match just the red, right, than matching red and none of the whites, if that makes any sense. So we'll do this little Powerball simulator. You generate a winning ticket. And this idea of this get winnings method or function in our class. We're going to have a class for Powerball ticket that has attributes. So the attributes for the white 5 white values and 1 red value, right? And this method, get winnings here. We'll talk a little bit more about this in a little while. I'll look at some other classes. I know we're out of time, I'm sorry. But I wanted to get this out for you here. And we're just going to keep track of total spent, money won, and the net loss. I'll give you a pro tip here. If they're not losing money, you did something wrong. Right? The more you play, the more likely you are to lose money. Now, sure, it is possible they hit one of these high value prizes early on, but the more you play, the more you'll lose. Right? So if you win early, sure, then maybe you won a little bit of money here, but you just keep saying, hey, buy 1,000 tickets, buy 1,000 tickets, buy 1,000 tickets, buy 1,000 tickets. You'll see you start losing fast. That's sort of the goal there. All right, so I've got to run. Class is over. Sorry to keep you long here. We'll talk more about this as we're going, but I wanted to get this out there so you can start thinking about it, have a little bit of time, and it's worth a lot. So I'll put the rubric up in a little while, and we can go from there. This one is due then, what was that, December 13th, I wanted to say? Like 6 p.m. or so, or 3 p.m., I think, 3 p.m. And we'll go from there. All right, if you got any questions, let me know. You folks take care, and I'll see you Monday in lab then. Thanks, everybody.